All right, this is going to be the first day of 6-3 notes. Okay, so we're going to take it up from partial derivatives, okay, and it's going to influence what we're doing today. So we're going to find the min or max of a function if both partial derivatives equal 0 at the same time. So I wrote it as f little x equals 0 and f little y equals 0. This will become extremely important on the second half of the notes. We'll talk about it later when we look at a big chart. So we'll talk about that later. All right, so definitely min and max. We talked about that a lot so far this semester. Min and max. Min and max. Okay. So let's look at the first problem and what we're gonna start with here. All right, so example 631. They're gonna give us the function xy equals x squared plus 2xy plus 3y squared minus 4x minus 3y. And we're going to find the critical point. Okay, so in order to do that, we need to find the partial derivatives. So let's do f little x. Okay, and again, we're going to take all of the pieces that involve x. Here's my x's. So I get 2x plus 2y minus 4. And then f little y gives me, here's my y, here's my y, here's my y. I get 2x stays the same plus 6y minus 3. Okay, and we're going to take this back, and this says take these and set them equal to 0. Okay, so I've seen systems of equations in lots of ways where students like to put them and say set them both equal to 0 and put the entire equation equal to 0. I don't really like to do that, but I'm going to show you how that's written out. So they like to put 2x plus 2y minus 4 equals 0, and 2x plus 6y minus 3 equals 0, and do systems of equations that way. But traditionally, when we take algebra courses, we move these two pieces right here. We're going to take these and move them to the other side. Okay, so I'm actually going to worry about 2x plus 2y. I'm going to add 4, and 2x plus 6y, and I'm going to add 3. And I'm going to perform systems of equations with this. Okay, but I can't just eliminate right away. So I'm going to have to multiply the bottom equation by -1. So let me go back and show you, hey, I'm going to take this one and multiply by -1. We'll write that on the next page. Okay, So the top equation stays the same, 2x plus 2y equals 4. And the bottom one becomes negative 2x minus 6y equals negative 3. Add straight down, I get negative 4y equals 1. Y equals negative 1/4. Okay, and then I have to plug that back into one of the two equations. It doesn't matter which one. Most students pick the first one. 2x plus 2 times negative 1/4 equals 4. I'm going to tell you right now that come a quiz and or a test, I will tell you right now, let me put it in red, must be a fraction. We're not changing these to decimals, okay? Decimals get rounded. I don't want any rounding. So we're going to change them as we're going to leave them as fractions, okay? So I get 2x minus 1/2 equals 4, okay? For those of you that aren't super handy with your calculator, the easiest way to do these, and I teach these in intermediate algebra, I say, hey, let's take this 2 and multiply through by 2. So I'm going to multiply through by 2. And then I get 4x minus 1 equals 8. Yes, I'll get a fraction as an answer, but I don't have to work the equation that way. So 4x equals 9, and x equals 9/4. We're looking for a critical point, so you must write it as a critical point. 9/4, negative 1/4. Okay, so critical points we said on the other page. Let's go back. That we wanted to look to see if it's a min or a max. Okay, so let's look at that. We need to figure out, well, is it a min or is it a max and all of that good stuff. All right, so we will eventually get into that. That will be the next day. But let's kind of look at some general graphs. So let me go to a brand new page, actually. So we're going to switch to Wolfram Alpha here in a minute. So we're going to look at graphs. I'm just going to put Wolfram on here. And first, I'm going to look at x squared plus y squared. Okay, so let me share on this one. Way to do it. Let me see. I want to share screen to Wolfram Alpha. Okay. So if I plot x squared plus y squared, we're looking in 3 dimensions. And 6-1, we kind of looked at this already, but we didn't get to see the grand, big old one that we need to look at, the big guy here. So when x squared is positive and y squared is positive, you get a minimum right in the middle at 0, 0. Okay, we scroll down on this page, they will flatten the bottom out so that you can see right here at 0, and 0 is that minimum. Okay, so when we talk about this in the classroom, and I'll write this on the other page when we get to it in a minute, I say, hey, what do you think happens when I put 2 minus signs on it, when I invert everything? And most students in their head, they don't normally respond. And they say, well, everything's just gonna, go in reverse. Which is exactly what happens. We get it so that there's a maximum at 0, 0. And again, they flatten it out. This shows that we're up on the top, which is why it's so light. And again, it's at 0, 0. The interesting one comes into play when you have only one of them negative. So if I have x squared minus y squared, Okay, so let's look at what happens here. This one gives me a saddle. So it looks like a saddle that goes on a horse. And what happens is we have maximums in one direction and minimums in the other. And again, they flatten it out in the middle there to show you, hey, there's maximums over here on the highs, and there's minimums on the other end. Okay, so let's kind of write some of that down. Let's go back to our whiteboard. Let's see if I can find that one. Uh-oh. I think my whiteboards all went away. This happens. Okay, so we said we were looking at the graphs. X squared plus y squared became a minimum. Negative x squared minus y squared is a max. And x squared minus y squared is a saddle point. Okay, probably should have put a little bit of a space there, sorry guys. And that means that again, there's a max in one direction and a min in the other. Okay, the original example, if we were to pare it down, go back to example 631, which again, my whiteboard disappeared when I went to the other board, ended up having an x squared had 2xy and a 3y squared. So we had some other numbers, but it was a positive x squared and a positive y squared. So at the end, you would have determined by a guess that it was a minimum. Okay, we'll get a whole system here on day 2 on how to do that. Okay, let's do another problem. Yep, all my whiteboards disappeared. It's okay, we'll go back to this one now. Okay, we're going to do example 632. F of x, y equals x squared minus 3xy plus y squared. So again, if we were to just look at the very basic part of this, you have a positive y squared and a positive x squared. So it's probably going to be a minimum, but let's go through the steps. First, take the partial derivatives. So the partial with respect to x is 2x minus 3y. And the partial with respect to y is negative 3x plus 2y. Again, we're going to set both of those equal to 0. 2x minus 3y equals 0. Negative 3x plus 2y equals 0. And to get rid of them by elimination, I'm going to multiply the top by 3 and the bottom by 2. So 6x minus 9y equals 0. And negative 6x plus 4y equals 0. And I get a negative 5y equals 0. So y equals 0. And when we plug it back in, 2x minus 3 times 0 equals 0. 2x equals 0. X equals 0. I get the critical point in 0, 0. And again, we think it's a min. Possibly. All right. The last thing I want to do on this lesson is talk about second partial derivatives. So yes, we had derivatives, and yes, we are also going to have second partial derivatives. Okay. So these will come in handy in the next lesson. So it's going to ask us to find the second partial derivatives of, here's our function, f of x, y equals x squared plus 3xy plus 5y cubed minus 7x minus 11y. Okay, just like with partial derivatives, in order to find second partial derivatives, we're going to have to find first partial derivatives. So the first partial is 2x plus 3y minus 7. And the first partial with respect to y is 3x plus 15y squared minus 11. Okay, so let's look at these. We're going to have this first. This says the first partial with respect to x. So yes, I get colors, and this is going to be actually super helpful. This one refers to this one right here. And then it says, hey, we're going to now take the partial with respect to x. Well, the only term that has an x involved here is the first term. So I get the second partial with respect to x is just 2. Sometimes there are variables involved and sometimes there's not. So it just depends. All right, so the next partial I like to look at is fyy. Okay, so this one will refer to, the first part refers to which partial am I looking at? Then I'm going to go and look for anything that has a y term in it in that partial derivative. So I'm going to take the derivative of 15y squared and I get 30y. All right, there are 2 more. I also have mixed partials, which are fxy and fyx. Okay, so again, these colors are super, super helpful. This one says take f of x and take the partial with respect to y. Okay, so we're going to go up here and look at this one. Oops, I don't want that. I want black. And I get just 3. So here I'm going to look at fy and then take the partial with respect to x here. Oops, let me highlight. That's this term. And I get 3. And what should happen here is I should absolutely get the same number for the partial derivatives, the mixed partial derivatives, sorry. They absolutely are the same. So that when you use it for a calculation, we will be able to use the same number. It's a great double check. So the mixed partials, these guys right here, are expected to be the same. All right, so let's talk about the homework for this new first section. Because we're splitting it into 2 days, I would recommend 6.3 in the textbook. Okay, you're going to do 1 through 4 and do the first 3 bullets. Okay, the third bullet is graphing f of xy, which is just like number 3 on 6.1 classwork. Okay, so definitely practice that. Okay, we didn't go over it here, but I think you can go back to the notes and look at it there. All right, so that's the first part of 6-3. We'll put more together for the second half of 6-3.